So let's open a new document and see how to define the model of our building. We can draw freehand using the parametric objects available here in the Objects archive, such as the building envelopes, floors, stairs, doors, and so on. Or we can even use a normal DWG DXF CAD drawing used as a reference to insert the various architectural entities automatically. We also have the possibility to use magnetic grids, very useful for defining the building's floor plans. In fact, here we can set up the dimensions of the individual grids. And then position them accordingly. So let's proceed now with drawing the walls. We can draw the wall entities by using the magnetic grid references as seen before. We can therefore insert these entities manually using the snap points supplied by the grid, or even generate them automatically with the Magic Wand tool. This feature allows me to speed up the modeling process by recognizing the entity size and position from the CAD drawing. We can then easily edit our wall objects by stretching, adapting, or maybe deleting them wherever necessary. We can insert new walls and change their parameters appropriately, let's say to insert internal partition walls. During the modeling process, we are also supported by quick alignment features that allow me to determine distances from certain objects or from certain points. So let's now finish off inserting these walls in the floor plan view. And notice that we have also modeled our floor plan in the 3D environment also. Another interesting aspect with regard to usability during the modeling process is that we can also work in 3D view when working in 2D view. This, of course, depends on how we feel more comfortable with the design process. For example, let's insert an opening here directly in the 3D view. With great simplicity, we can continue to edit the object characteristics and the geometry even after insertion. In this case, we can modify the geometry of the opening, maybe add a wooden frame around. Let's continue to insert other doors, this time in the floor plan view. We'll select the door entity, and as with every other element available in Edificius, we'll also choose the desired model from the catalogue. Of course, we'll be taking a closer look at the various types of catalogues afterwards in the presentation. So as you can see here, we are easily positioning our doors, defining the side and the opening direction. We do this by using the function keys F7 and F8. And to conclude this phase, we'll insert these other door types. For example, this model here with the 2 door leaves and this front entrance door here. Here we go. And to conclude, we'll now switch back to the 3D view, where we can see the result of our modeling and even continue to work from here, adding other details to the doors. Maybe we want this to check the opening directions. And make any final adjustments. So far we have seen the initial stages of the modeling process by inserting walls and doors, but let's now take a look at how we can proceed by drawing the floor slabs. These parts of the building can be modeled by using the horizontal envelope object and by choosing a material layer type. Again, drawing is supported by using the snap aids provided by the surrounding objects. Let's finish the inserting of our slab and verify the result in 3D view. Now let's add a very important object, which is the stair object, to our model. When it comes to designing stairs, we need very flexible modeling tools. In fact, we have a dedicated editor here in Edificius. This in fact allows us to easily customize the shapes and forms of each component. In Edificius, we have made inserting stairs very simple by using 2 main objects. These of course are the ramps and landings. And by means of the editor, we can edit the individual shapes and geometries at will. In this example, we are going to insert 2 flights of stairs and a landing, and then modify their geometry. In fact, here in 3D, as soon as we connect the landings to the 2 ramp objects, the program automatically recognizes how the stairs are going to be built, and therefore completes the modeling for us. We'll make a copy here of the landing, reposition it into place, and as seen before, we can go and have a look at the 3D result. Now we'll finish off the modeling by inserting a railing object. This time we'll insert this type of object directly within the 3D view. Again, using the various reference points on the staircase object now, the magnets on the staircase here continue to guide us during insertion. We now need some windows, so this time we'll continue to work in 3D. We'll choose the window object and insert a first type of window, as you can see here. We'll then choose a different model from the catalogue and insert this object just as we did with the door object. We can insert curtain walls and other types of glazing. And just as seen with the windows, we will choose this first model here for our staircase. And the second model for these spaces on the side. Again, we can freely switch to the 3D view, where we can make any final adjustments and changes if needed. So far we have inserted some of the main architectural entities, but we definitely need to add some color to our project. So let's quickly see how to apply materials. To apply a material, simply select the paint bucket command here from the menu. Choose a material from the catalogue and simply apply it to the various entities. Let's go ahead and apply this red paint on the walls of the staircase. We also have other possibilities of doing this. We can in fact acquire a material from an object and apply it to other objects. We simply sample a material using the sampler tool. Maybe we need to acquire the material used on these windows and use it for other objects too. Not only can we copy materials from one object to another, but we can also copy entire objects together with all of their features, whether these be present in the current project or used in other projects. For example, let's use a window already customized in an old project. And use it directly in our current project. Let's now close this old project and continue to work with our new project. How about mirroring entities? Let's see how to make a symmetrical copy of our model so as to finish off the modeling of our floor plan layout. As you can see here, this is a quite simple process. Requires a simple copy-paste action. Then all we need to do is simply use the 2D object grip here and place the copy models at a desired point. So as you can see, we have terminated our floor plan design. Now all we need to do is simply develop our building in height. At this stage, we need to access the program's height reference system and create various other levels. These are used to subdivide our building. An editor that allows us to easily create the required levels, set their dimensions and heights according to relative or absolute elevation values. Once we've created the required number of levels, we can then move on to the copy function. Here we can choose to automatically copy specific entity types or all of the entities to the newly created levels. As you can see, this powerful tool allows us to quickly copy our previously designed floor plan to all of the levels in the building. As said before, we can also copy single elements. For example, let's insert a railing at ground floor. Now you'll notice how quickly we can copy the railing to all of the upper floor levels with a simple click. Now that we have obtained something more like a building, let's take a look at the 3D view with the Shadows Simulator active. This is in fact a precise dynamic shadow simulation which takes into account the building's geographical coordinates and the altitude, the day and time of the year. A useful tool for studying how sunlight and shadows will affect our building. Let's now assume that the first stage of the modeling process is now complete. We now need to produce some of our construction drawings. First thing, we'll use the floor plan object to quickly generate a floor plan view. Here we simply define the cutting plane height. We also need a cross section. In this case, we'll just make it pass through our staircase. And finally, a front and side elevation view. You'll be able to notice that as these drawings are generated, the relating node is added under the Drawing Models node in the Project Navigator. Let's now open the floor plan. Here we can see that we have various different predefined representation styles. We have the minimalistic illustration type together with other more colored styles too, useful for large-scale drawings, etc. All of these styles can, of course, be customized, and we also have the possibility to create our own personal styles too. What would our drawings be without any classic architectural detailing? The program, of course, also supports 2D graphical objects which allow us to complete the modeling representations. Here are just a few. We have the drawing scale symbols, material layer composition, and so on. Further detailing also includes the possibility to measure up individual rooms manually. Or maybe just insert the measurements automatically and allow the program to do the measuring for us. Once we have set up our drawing models, we can of course print them directly and create a working drawing layout. Easily choose the paper size, the type of title block and its position. And after configuring our working drawing layout, all you need to do is simply drag and drop the desired drawing model into place. At any time, even before printing, we can still make whatever changes we feel necessary and dynamically update all of our drawings throughout the BIM model. This is what we also call the inverted philosophy. If we modify the 3D model, the drawings are also updated automatically, or vice versa. We can even make our changes from within the drawing model, and notice how the 3D model is updated consequently. Let's now modify one of the windows here freely, and notice how these very same changes are extended to the working drawings. These were previously prepared for printing. Let's now close this project and open up a different one to see other features. Let's now move on to seeing how to work with materials. Previously, we had a brief look at how to apply materials, selecting them from the catalogue. You can notice here that we have this globe type icon next to a material. This indicates a high quality 3D material. These types of materials have enhanced realistic effects when viewed in the real-time rendering environment. Edificius comes with a variety of materials that are already available in the program's general catalog, but we also have the possibility to access the online catalog where we can download a wide range of additional materials. The online catalog provides us with thousands of items classified by entity type, for example 3D models, doors, windows, section profiles. And not only can we download objects from the catalog, but we can also upload our own and share them with a continuously growing community of users. Let's now go back to the model. Here we have downloaded a series of high quality 3D materials so that we have them instantly available whenever we need them. If we activate the realistic view, we can see that these particular materials have a very high definition. Applying these materials to our model, such as this stone material, and cover the entrance wall and the fireplace, we will then apply the parquet to the floors. In this case, to make things a little easier, we can hide the windows here and continue to apply the plaster on the front facade. The gravel at the front entrance, and to finish off our material application, we'll choose one last material for our roof. How about addressing outdoor accommodation and entourage? To do this, we have a dedicated terrain editor. So simply switch to the terrain environment. We'll now delete the existing terrain and draw a new one. We can draw freehand using the contour lines, use the elevation nodes, or even load a topographic contour plan deriving from a land survey CAD drawing. Or we can even import it directly from Google Maps. We can in fact integrate Edificius with Google Maps. Simply select an area of interest and automatically import the entire terrain area, including its satellite imagery. Going into more detail, we can also make adjustments to align the terrain to the building, both in plan view and of course in terms of its altitude. When the object grip is activated, we simply move it into a position with known coordinates in space, and we'll then place it at a known reference point on the model. For example, in this case, at the base of this perimeter wall. We can then proceed by modeling the terrain with dedicated features. We can represent our earthworks with appropriate objects. And notice how the terrain modeler automatically generates the embankments too. Here we can specify a depth value and use the model as a reference. The editor also provides us with other objects, so let's continue seeing a few more, such as the flower beds, and the swimming pool, and how about the materials? Let's change the texture here used for our terrain. And to finish, we can use another dedicated object for vegetation and trees. We'll insert these 2 lime trees on the sides here. Maybe a different type of essence for our flower bed. And to conclude, we'll insert this olive tree here. After seeing how to work with materials and how to build a small outdoor accommodation, we can now move on to see the results of our design choices directly in the RT-BIM, or the real-time BIM. To understand the great potential behind real-time rendering applied to BIM design, we'll now close this file and open the same project where we have continued to work on inserting further details and objects. So let's open the project and access the real-time rendering view. Thanks to this example project, we'll be able to quickly understand how the integrated RT-BIM environment isn't only a powerful representation tool, but also a valuable and useful support tool for use during the design phase. Of course, this helps us to make our design choices in a more conscious and controlled way. We can move freely within the model, as you can see here. Just have a look around. Or we can even create predefined paths. This of course can turn out to be very useful to produce video presentation of our project. These paths are easily created by simply taking pictures in specific positions. Once we've created a pathway for our scene, we need at least 3 different positions. We can play the animation, and if everything looks okay, we can even record HD video. Let's have a look at a few photoreels here created for the project to see an external overview of our model. Let's have a look at some of the real-time rendering features and notice how realistic these kind of visualizations can be. In fact, we can see the waves here in the water dynamically, the plants that sway with the wind. Even notice this photographic effect on this bamboo here, which is slightly blurred. We can even run a shadow simulation to study how shadows and sunlight affect our plants around the pool or in the garden. Let's have a closer look at this pathway for our interior design too. We can appreciate different effects such as the quality of materials or the effects of lighting. And the reflection of the clouds on this glazed entrance. Let's now concentrate more attention on the internal configuration. Here we can study the natural sunlight that bounces into our living room, and if necessary make small adjustments by changing the size or the position of our windows. Let's run the animation again to see the resulting effect. Taking a look outside, this time using a different view with the climate effects, we can even activate a rain effect, fog, and even the effects of wind in the trees, and even make adjustments according to the type of scene. Let's now turn the lights on in the garden and run the animation. Here you'll be able to notice the effects of wet materials and how they change appearance when we switch the rain effect off. All of this in real time. Before we mentioned the importance of having real-time rendering integrated within the model. Let's see another example to understand what this means. We can make any changes to our project at any time during the design phase and see the results of the real-time rendering view. For example, we can move objects around or modify the facade by modifying or eliminating a window. It's all updated dynamically in the real-time rendering view.